Picture a high-speed factory line where hundreds of parts move in a perfect blur. Right now, there is a problem. A microscopic misalignment in the feed track is creating tension, and the entire system is seconds away from a complete mechanical failure. The digital sensors show no errors, but Bob recognizes the sound. He's been on this floor for 20 years. He doesn't need to consult a manual or run a diagnostic. He simply hears the specific rattle and steps in. He reaches past the main control panel and taps the left latch twice in rapid succession. The tension releases. The gears smooth out. The line continues. That double tap isn't in the official documentation. It's an unwritten workaround, a piece of physical intuition developed over decades. This is tribal knowledge, the specific, undocumented feel of a machine that veteran operators use to keep production moving. While industrial code and robotics drive the line, this invisible layer of human expertise acts as the actual engine that prevents downtime in the real world. Standard IoT sensors track variables like temperature, but have a distinct blind spot. They cannot log nuanced human movements. Official manuals offer no help either. These static documents are disconnected from the practical realities of the factory floor. This creates a significant operational risk because next week, Bob is retiring. When he leaves, 20 years of specific operational intelligence leaves the building with him. New hires will follow the official manuals, which lack Bob's physical shortcuts. This leads to longer repair times and repeated stoppages for the exact issues Bob once resolved in seconds. The challenge is finding a way to capture this fleeting expertise, to translate human intuition into permanent, usable data. Hackaback's EFM Fact Story serves as an autonomous historian for the factory floor, using edge-native vision language models to observe and transcribe human expertise as it happens. Running on NVIDIA Jetson hardware to function as a secure point of data generation, turning visual observations into structured intelligence. Consider an operator assembling a complex bill of materials. As they work, they describe their actions, noting why they are tightening a specific valve or adjusting a tensioner. Fact Story's multimodal integration allows it to watch the physical steps while simultaneously transcribing the operator's spoken instructions. The AI combines these inputs and generates a detailed written guide of the task. By simply performing the work, the operator has created a new, accurate standard operating procedure. When a defect is detected, Fact Story uses root cause storytelling to look back through the visual history of that specific batch. It identifies the exact moment a variable changed, like material loaded at a slight angle, connecting that physical cause to the eventual machine outcome. The system provides a chronological narrative of the floor, creating a record of the factory's operation based on visual facts. It is 2 a.m. on a Tuesday, months after Bob has retired. A junior operator encounters the same rare fault on machine B that Bob used to fix. Rather than stopping the line to search through a generic manual, the operator asks the EFM kiosk, "How did Bob fix this?" The system instantly displays the visual and text narrative of Bob's original fix. The operator sees the exact latch top required for this specific state. They clear the fault immediately, bridging the knowledge gap without needing a senior staff member present. EFM Fact Story treats the factory floor as an ecosystem of human expertise. It makes the hard-earned wisdom of the workforce a permanent part of the factory's operational data, ensuring that specialized skills are preserved and accessible to every operator who follows.